Okay, we've got our presentation ready, so we've got another lesson about angles, and this one particular lesson is talking about parallel lines and transversals. So we do have a little bit of bell work we'd like to start with. So this first problem is a vertical angle problem, and in it we can see that we know that 3x minus 4 and 107 are across this little vertex. So that means they're going to equal each other. And we're asked to find x. So if we set them equal to each other and solve for x, we end up with 107 plus 4, which is 111, and that equals 3x. And when you divide by 3, you can use your calculator, or if you don't, have your calculator handy and you're not quite sure what that is, you can go ahead and do it the long method. So 111 divided by 3, and that goes in there 37 times. So x equals 37 degrees. Okay, on our next problem, we're talking about this triangle here, and we know that from the triangle sum theorem that the three angles of a triangle add up to 180 degrees. So we know two of the angles, so if we combine those together, 35 plus 113 equals 148 degrees. We're going to take that 148 degrees and we're going to take it to the other side and subtract it from 180 in just a moment, after we've kind of shown you how that looks like when we've simplified the left side. So there we go. We minus 148 from both sides, and we end up with x equals a very nice, very easy to handle 32 degrees. So that means that the third angle of this triangle is 32 degrees. All right, so that is an obtuse triangle with two acute angles and one big obtuse angle. This next one, we're dealing with the exterior angle theorem. And so we know that from this theorem, that this angle on the outside of the triangle right over here is equal to these two interior angles on the opposite side of the triangle added together. So that x equals 147 degrees. Now we're going to hurry and review a couple of concepts here. What are vertical angles? Well, vertical angles are angles that are formed when you take two straight lines and just basically crisscross them or intersect them. And so these angles that are formed by intersecting lines turn out to they create a couple of pairs of vertical angles. All right. And it turns out that vertical angles, when you compare them, are congruent. So if you can find a pair of vertical angles, you know that they have the same measure. Okay, what are supplementary angles? Well, supplementary angles are two angles that add up to 180 degrees. So their sum, when you add the two together, is 180 degrees. So we've kind of just talked about that in the past, but those theorems or definitions are going to come in handy. Now here's a diagram that shows some supplemental angles and some vertical angles. So we're going to kind of list them here and show you all the different possibilities. But in this particular problem, which you'll see on Alex, is a sample question, and they want us to know what are some supplemental angles. Well, I'm going to go through here and circle all of the different supplemental angles. The two angles that are next to each other or adjacent, that if you added them together would equal 180. There's 4 right there. And if we keep going, we can also do the ones that go up and down. So 8 and 7, 6 and 5. And the next one, 4 and 3. And then the last one, 2 and 1. These would all be pairs of supplemental angles. And we only need to write down one of them. So just pick one and write it down. So I think I picked the one 2, 4 because that's the first one. So one pair of supplemental angles would be 2, 2 and 4. You know, vertical angles are just the angles that are diagonally straight across from these intersections, like 6 and 7, as you see, 2 and 3. If you look at the other ones, 5 and 8, and 4 and 1. Those are angles that are across an intersection from each other, so they're called vertical angles. And we know that they're congruent. So I wrote down 1 and 4, but you could have also written 2 or 3, or 6 and 8, 6 and 7, or 5 and 8. So there you go. You got a bunch of them that you can use. Okay, moving on. So on the next thing on our list here is a little bit of vocabulary. So in our first little picture, we were talking about perpendicular lines. If you see a little right angle mark there in the corner, that's a 90-degree angle. So these lines cross on a 90-degree angle, which means that they are considered perpendicular lines. This next one at the lower part of the diagram, a transversal. A transversal is just a line that crosses 2 parallel lines. And then what do we mean by parallel lines? There's 2 lines that never intersect. And this little arrow that you can see at the top of each one is kind of an indication that those are parallel lines. All right? So if we wrote these little definitions down on your guided notes, so this is what they're going to look like. So parallel lines are 2 lines. 2 lines. That looks like a line, but it's a line. 2 lines that do not intersect. So they can go right along the side of each other, but they never start to curve over and intersect each other. They always stay away from each other and keep going in their own direction. All right. Meanwhile, we have the idea of what is a transversal, and that is a line, any straight line that will cut across 2 parallel lines and create kind of a situation or a set of angles that we can use to describe and understand some relationships between the angles. So a line that cuts across parallel lines is called a transversal. Now just a reminder, supplementary angles are 2 angles that add up to 180 degrees. And you see a lot of those on these relationships between parallel lines and transversals. There's a lot of supplemental angle relationships. Okay, so here's a set of parallel lines and a transversal. So the 2 parallel lines are lines M and N. So lines M and N are the parallel lines. And then the transversal in this case is the line that cuts across them and that kind of that slant off to from the lower left to the upper right. So that line is line P. And so we're going to write down line P there. Sometimes there's some other types of notations that you can use to indicate line P or lines M and N. But for now, this will be good enough. Okay, so now we're going to talk about some angle relationships. So we've got a parallel lines and a transversal. We want you to name and highlight the vertical angles. So the angles that are across each intersection on a diagonal. So I'm going to highlight them with the same colors. So 1 and 4 are vertical angles, 2 and 3, 5 and 8, and 7 and 6. So if you can do the same thing on your notes, highlight those vertical angles in the same colors so that you won't forget them. Next, we're going to name and highlight the corresponding angles, or angles that are in the same position in the diagram along this transversal. So 1 and 5 are in the same position. 3 and 7, they're in the lower left-hand corner. 8 and 4, they're in the lower right-hand corner. Okay, and then the last 2 angles are 6 and 2. They're in the upper right-hand corner of these little diagrams. So those are also corresponding angles. Now we're going to name and highlight the alternate interior angles. These are angles that are on the alternate side of the line and are on the interior of the little diagram. So we're going to change to a highlighter here. So angle 3 and angle 6, so you can see they're on the opposite sides of the transversal inside of our diagram, and angles 4 and 5. Those are called the alternate interior angles, and they are congruent with each other. So the angle 4 and 5 are the same measure as angles 3 and 6. Okay, so the next ones we're going to highlight are the alternate exterior angles. So you're going to highlight that number 1 and number 8. So these are on the outside of the parallel lines, meaning on the exterior, and they're on the opposite sides of the transversal. So 1 and 8 and 2 and 7 are called alternate exterior angles, and they are also congruent. And you're marking these on your highlight notes. Okay, name and highlight the same interior angles. The same side interior angles are supplementary. So if you look on the inside of the diagram, you got angle 3 and 5. I got to get that highlighter again. So angle 3 and 5 are on the same side of the line, and they add up to 180. And angle 4 and 6 are on the same side of the other side of the line on the interior of our diagram, and they're also congruent. Or they add up to 180. Now we've got same side exterior angles, 2 and 8, and okay, we marked one on the inside. We want the exterior angles, so we're going to have angles 7 and 1 are also another pair of alternate or same side exterior angles, and they are also congruent. They're supplementary, meaning that those two angles add up to 180 degrees. So if you know one, you can find the other. If you know the measure of one of the 8 angles, you can find the measures of all others in the whole diagram. Let's try it out. So if the measure of angle 1 right up there in the upper left-hand corner is 120 degrees, then let's go through and write down, so we got 120 there. And then vertical angle 120, corresponding angle 120. So we got those 3 120 degree angles. And I'm using a pen that actually types it after you write it. So I'm going to go back and I'm going to delete those numbers here in just a minute and write them in so that they kind of fit on the diagram a little bit better. But in essence, those 4 angles are all 120 degree angles. So there we go, 120. Let's go ahead and show them to you now. We'll write them down. So I kind of reversed the video so you can see them disappear, but there's 120, 120, 120 for number 5, and angle 8 is also 120. So if those angles are each 120, then to find the other angles, all I have to do is subtract 120 from 180. So 180 subtract 120 equals 60. And that means all of the other angles in this diagram are 60 degree angles. Wow, that's pretty powerful if you think about it. So even though these kind of look big with 8 different angles, you can actually find them very easily. And so as we go down through this list, these angles are either going to be 120 or 60. And so I'm kind of filling them in as I go, making sure that I write them on the correct ones. So there's all of my 60 degree angles, and now the rest of the angles are going to be 120 degree angles. And I was able to get that by, first of all, they gave me what the angle 1 was, and I used the idea of vertical and corresponding angles to find all the other angles that were the same. Here's another diagram. Angle 1 is 72, so that means that the angle across from it, angle 6, is also going to be 72. The corresponding angle in the same position is angle 3 at 72, and its vertical angle is angle 8. So angles 1, 6, 3, and 8 are all 72-degree angles. All right, to find the other 4 angles, we just need to subtract 72 degrees from 180 degrees. And when we do that, we're certainly going to get the numbers we're looking for. And we end up with 108 degrees. So all of the other angles are obtuse angles of 108 degrees. So I hope you're finding and seeing the power of these diagrams and being able to look at angle relationships. Okay, so here's another diagram. It says, find the angle measures given 2 parallel lines cut by a transversal. So they give us some information. They say that angle 3 is 43 degrees. And then they ask us, well, what would angle 6 and 8 be? Angle 6 is going to equal 180 degrees minus 43, because angle 6 corresponds to angle 7, and which, so angle 3 and angle 7 are kind of the same value, and so we have to subtract 180 minus 43 to get 137 degrees for angle 6 and angle 8. All right. So hopefully you're seeing the power of this, and these are just some of the examples from your Alex assignment. So your assignment is Parallel Lines and Transversals, Part 1.